The topic that I'll be focusing on is the properties and features of three-dimensional shapes, which falls under the category of geometry. The activity I chose consists of students being able to classify and describe 3D shapes while being able to identify the correct nets of the three-dimensional shapes. Students will identify the properties of the 3D shapes and apply it to Eulers Theory. According to Osvalds, this subtopic falls under level 5. Students connect three-dimensional objects with their nets and other two-dimensional representations. For this topic, students will be describing, justifying, reasoning, visualizing, and explaining the properties and features of three-dimensional shapes, which are all key mathematical skills. Students must have prior knowledge and understanding of describing and classifying three-dimensional shapes. Students must also have prior knowledge about the properties of shapes, which are the faces, edges, and vertices, and they should be able to identify them. Okay, so to begin this activity, each child will receive a net of a three-dimensional shape, which will look something like this. So for my activity, the student will have to cut around the net of the three-dimensional shape so they construct it. So this is one I prepared earlier. So here is a net of a three-dimensional shape, which I have put together. So this is the pyramid. So what the student will have to do is calculate the properties of the three-dimensional shape, which are the faces. So the faces are the flat surfaces on the three-dimensional shape. The edges, so where the two lines meet. And the vertices, which are the corners, the big pointy bits. So to apply this to Eulers Theory, we need to calculate the faces, so F, plus the vertices, which are the corners, minus, so take away, the edges, which are where the two lines meet. So Eulers Theory always equals 2. It works for any polyhedron that doesn't intersect itself, such as a cube or a pyramid, as I'm using now. So on a pyramid, the faces, we have 1, 2, 3, 4, 5. So we have 5 plus the vertices, so the corners, 1, 2, 3, 4, 5. Minus the edges, so 1, 2, 3, 4, 5, 6, 7, 8. How are you going with that, Amy?
Good.
You understanding?
Yeah.
Good job. Alright, so we've got 5 plus 5. What could you tell me 5 plus 5 is?
10.
10. So we've got 10. Take away 8. 10 take away 8 is?
2.
2. So that applies to Eulers Theory. So this is a polyhedron. So now I'm going to get Amy to do one on her own. So we have the cube. So I'll give Amy the cube so she'll be able to cut around it and construct the net. Great cutting skills, Amy. That's it. So there you have your net of your cube. That's it, Amy. So you're just folding on all the lines and then you'll be able to put it together to make the cube. Great, Amy. So now you have your cube. So now we're going to apply it to Eulers Theory, which I showed you before. So here we go. I'll help you out if you need any assistance.
So F for faces. 1, 2, 3, 4, 5, 6.
Yeah. So 6 plus the vertices. So what were the vertices?
The corners.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8.
8. So 6 plus 8 minus the edges. So what were the edges?
Where the meets.
Yeah, that's it.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Great work. So now we can work out the equation. 6 plus 8 is
14.
14. Take away 12 equals
2.
2. So there we see that it applies to Eulers Theory. And what does that mean a cube is?
Is a polyhedron.
That's it. Good stuff. High five. That's it.